Hello, this is going to be a beginner's tutorial on getting started with the Steinberg VST SDK for plugin development. A few things. I'm going to assume you've downloaded the SDK and you've managed to use the project generator that comes with it to generate a starter project. And that's where I'm starting. So I've just generated an empty instrument project using the VST project generator that comes with it. I'm not going to go through those bits because the stepwise process for getting CMake installed and things like that is quite good online, and so I won't cover that here. Just for note as well, also comes with the SDK is a VST plugin test host that can be quite useful for debugging because it opens quickly, lets you see parameter values, things like that. I'm going to be using the one that comes with JUCE just because I think it's a bit nicer to use, but you can use either, it doesn't matter. So here's my generated project. And if you've used JUCE before, you'll recognize some of this. Basically, the main bits we'll be concerned with are the controller and the processor. So the processor does the audio stuff, basically, and the controller sorts out the UI and parameters side of things. As far as the SDK, the VST structure goes, these are meant to stay separate as much as possible. So one shouldn't depend on the other for anything because they run on different threads, and that's a whole other complicated thing. But you shouldn't share things between them except for the few accepted built-in ways to send things between them, but that's for another video. You don't need that for just a basic starter plugin. Essentially then, the controller sorts out the UI side and the parameters, while the processor just receives a audio buffer for in and out. It receives some information about sample rate, things like that. An input events list, which is basically the MIDI and control change side, and then a list of the parameters that were changed in the last block with the sample in that block they were changed at. We're going to go to the processor first, and a lot of this is boilerplate, so this will come with your generated project. Here's our process block, and for the sake of this tutorial I'm going to delete everything here. So here's our empty process method, and here's our process data. So this contains the input events, so the MIDI stuff, the parameters as well, and the audio buffers for the inputs and outputs. Something to note about the structure. So a VST plugin, a VST3 plugin anyway, can have multiple sets of buses which each have their own channels. So a stereo in and out would be one input bus, one output bus, each with two channels. But you could have, say, if you had a side chain input, that could be another input bus that would have two channels. Another thing to be careful of whenever you deal with anything in here is to make sure you, before you dereference the pointer, you check there's actually something being pointed to. So it's perfectly acceptable for the host to tell the plugin to not render any samples if it just wants to update the parameters or something like that. Something to note as well is before you use any of these, check that there's something there to dereference. So for example, it's perfectly valid for the DAW to send a request for 0 samples, in which case your num samples will be 0. And for example, your input and output channels could be null. And so then if you have logic which always dereferences those to fill them up with something, you'll fail the validator and you'll get an error in your build. I'll show you that now. So the first thing I'll do in the process block, I'm going to check that the block is more than 0 samples, because we don't want to do any processing if the host has asked for 0 audio samples. The next thing, we'll get the number of buses. So data dot, we'll use the max of the in and out. Num inputs, num outputs. So that's our number of buses, which remember can each have channels. Just for quick to show you, for an example, this is for the pointer for the buses. So this is the first bus, first input bus, and the second channel of the first input bus. This is the same for the outputs as well. So now we got the number, we will loop for each bus we have. Then for each bus, we will find how many channels are in that bus. I'll just use the outputs for now, but you would make this more robust. So this is looking at the B output bus and then getting the number of channels in that bus. Then for each channel in that bus, yeah. Now we can actually do something with it. So I'll get a pointer to the channel. So let's get input equals data dot inputs, and then we want the bus input. Then channel buffers 32 and 64. These are just to do with if you're using floats or doubles. Floats are fine for almost everything. And you're not going to get an improved sound quality by using doubles unless you're doing some advanced filter stuff. So channel buffers 32, and then that's our channel. Our sample would be like this, say 5th sample of the C-th channel of the B-th bus. But we just want a pointer to all the samples. Then let's get our output, same way. There we go. So we've got 2 parallel channels, the input and the output of the respective channel. And now let's just use mem copy, and we'll check that audio goes through okay. So our output is output, input is our input pointer. Our size is the size of a float value times how many samples we're moving, which will be the number of samples requested in the block. So let's see if this works. Let's build. And here's the JUCE audio host. Here's our inputs, here's our outputs. So that's a bus, that's a bus. Let's connect it to this built-in Sine synth and we should get the audio out the other end. So now we've got the audio going through, okay? We'll add something to make a sound. We're making an instrument. So just in sources here, I'm going to add a header file. To put this in the source folder. Here. And we'll call this oscillator.h. And we'll add the include guard thing to stop any issues later. So let's create a simple oscillator class. So we'll want, first thing we need to do is have a method to set its sample rate and stuff, because the oscillator will need to know the sample rate. So void set sample rate. You can use an integer. And then we'll create a variable, a class variable. We'll call it, give it a different style, and we'll just get that from this method. Next, we need something to fill the buffer that we get handed. We'll be handing a buffer to this oscillator. So I'll just call it get block. Our input will be a pointer to some floats, like our audio buffer. If you're making in the future an instrument, you'd be best using vectors for moving the audio between different classes, between different objects in your instrument. But for now, we'll just put it in the same type as the output buffer, as we're just testing something. Then we'll do a for loop, and for every sample, we'll call a private method called, let's say, getNext, that returns our sample we want. And we'll have a little method just to set the frequency. We'll use frequency equals, we'll default that to 440 Hertz. And set frequency. I've just used the M here to indicate it's something that will be changed by the owner of this Sine object. Now let's make what we need for the oscillator. So we'll need a current time or 0. We'll also need a time step, which will be how much we add each sample. While I remember, we'll calculate that time step here when we set the sample rate, because that's the only thing it depends on. So that's just 1 over the sample rate. So in our getNext, we will add our time step to our current time. Mr. T off there. If that's above 1, we'll subtract 1. There are ways to do this without the if conditional statement, but sorry, I forgot. We need to multiply our time step by our frequency so that it increases. If this time step is 1 divided by the sample rate. So it would take a second to add. If, let's say, we're at 48 kilohertz sample rate, that would mean we're adding a 48,000th. So that would take a whole second, because it would be 48,000 samples. So if you multiplied that by 10 and it was adding 10 times that each time, it'll roll over 10 times as fast. So you get a 10 hertz oscillation. We'll just return the sine using sin f, because I'm in floats, of the current time times, we want 2 pi here, I think. I don't have the constants in, I'm just gonna that's not ideal. I'll come back to this. We don't have sin f. We'll include math.h. There we go. That all looks good. Now in our process header, I'll include our oscillator. And I'll make 2. Then I'll remember to go down to here, set up processing. This is called before any audio is processed, and I'll set the sample rate here. Whoops. So new setup dot sample rate, and that for the other oscillator as well. Now we can incorporate them into here. Simple, we don't need this anymore. We just need the output pointer because we're not using the inputs, and we go C, get a block, output, and data.numSamples. Now let's see if that works. Let's close the old one. And there we go, we got a sine wave. In the next one, we'll add a parameter to control it, and then we'll add MIDI to control it. A few things just before I end. This here, I know there's only 2 because I've enforced it here that it's stereo in and out. Otherwise, you'd have to work out how many oscillators or processors to make for your samples. But yeah, thanks for watching.